2024 A-Level Combined Mathematics Paper 2, Part A, question number 1. This question has to do with the conservation of momentum and the coefficient of restitution. The question says, a particle A of mass 2m and a particle B of mass m moving on a smooth horizontal table along the same straight line towards each other with speeds of u and 3u respectively collide directly. After the collision, A and B are said to move in opposite directions. The coefficient of restitution between A and B is given as E. Now with this information, we are asked to show that the value of E is greater than 1 over 8. Now to start off with this question, let's consider the situation that we have here. We have one particle A, another particle B on a smooth horizontal table. A moves towards B at the velocity of u and B moves towards A with a velocity of 3u. In this situation, A has a mass of 2m and B has a mass of m. Now after they go like this and they collide, they bounce back because they have some form of elasticity since they have a coefficient of restitution that's not 0, and with this the particle A goes one way and the particle B goes the other way. So here we can see if we have particle A of mass 2m, particle B of mass m here, particle A is going to have to move away from B, which means it's moving in this direction, and particle B needs to move away from A, which means it's moving in this direction. Now in this case, let's consider particle A moves at velocity, let's say v1, and particle B moves at velocity, let's say v2. Now, given this situation, what we need to do is to first apply the conservation of momentum and then later apply the restitution law to find out some equations that we can use in order to find the values of v1 and v2, our unknown velocities. So first off, starting with the conservation of momentum. According to conservation of momentum, if we apply I equals delta mv to this situation, since there was no momentum gained or lost, since there was no external force on the entire system here, if we apply I equal delta mv in a given direction by applying them as vectors, we can say if we apply them rightward, then in between the collision here, from the start to the end, there was no overall change in momentum I. There was no impulse. That's 0. But this 0 must be equal to the change of momentum from the first situation to the second situation. Now in this case, if I consider the rightward direction as being positive, then I would take mv2 as positive, but I would also take 2m times v1 as negative, since v1 is in the leftward direction, which is going to be negative. Therefore, the final momentum here is going to be mv2 minus 2m times v1. Now from this I have to subtract the initial momentum, which is going to be these two momentums added together, and here we can see this u is in the positive direction, so therefore it's positive. So we have u times 2m, but then we have 3u in the negative direction, so we have minus 3 times m times u. So therefore, here we can see we get 2m times u minus 3m times u. Now according to this we can see we get mv2 minus 2mv1 minus, and inside here we can see we have 2mu minus 3mu, which is going to be negative mu, and therefore we have minus negative mu, which is going to be positive mu, and therefore we get mu plus mv2 minus 2mv1 equals 0. Now rearranging this and dividing everything by m, we can see from this equation we are going to get 2v1 minus v2 being equal to u. If we rearrange all of this, we get u here, taking that the side we have negative u. If we multiply it by negative 1, we're going to get u equal 2mv1 minus mv2, and simplifying that we get this. I'm going to call this equation number 1. Now equation number 1 was found using conservation of momentum. We can also find another equation like this. We can also find another equation like this by using Newton's law of restitution. So the second thing we're going to do is to apply Newton's law of restitution to the system and try to find another equation. Now as we know, Newton's law of restitution says when you have two objects and they collide, if their initial velocities in this direction, let's say, are u1 and u2, and the final velocities are v1 and v2, again all in the same exact direction, the positive direction, then E is going to be equal to v2 minus v1 divided by u1 minus u2. You can see the sign swap on the top and bottom. Now considering this, in this particular situation we can see we have something similar to that, but in this case our signs are already swapped because this velocity is in the leftward direction and this velocity is also in the leftward direction. So according to that, if we apply Newton's law of restitution, we're going to get E equals, and I'll take V2 as being positive here. So we have V2 minus V1, but since V1 is already in the negative direction, it's going to be minus negative V1, which means the actual value here is plus V1. If you take the absolute value of this thing and we consider this as negative V1, then you have minus negative V1, which will be plus V1. And then we have that divided by U1 minus U2, and here since V2 was applied to the second object, then U2 is going to be this velocity, and therefore U1 is this velocity. So according to that, we have U1 in the rightward direction. That's going to be U1, which is U, and then minus, but then we have negative 3U, and then you have minus negative 3U, which means the final answer is going to be plus 3U. So therefore, we get E equal V2 plus V1 divided by U plus 3U. Now if we simplify this, we can see on the denominator we have 4U, and taking that to the other side we have 4EU. According to that, if we simplify this, we can see V2 plus V1 equal 4EU. This is going to be equation number 2. Now what we can do here is to combine equation number 1 and equation number 2 in order to find the equations for V2 and V1. Now in this particular case, we can see if we simply add equations 1 and 2 together, we are going to get this V2 and this minus V2 here cancelling, leaving us with 2V1 and another V1, which is going to be 3V1 equal to U plus 4EU. U plus 4EU. Now here we can see we get V1 equal 1/3, and if I take the U out here, I'm going to get 1 plus 4E times U. This is our value for V1. Now similarly, if I want to find V2, what I have to do is to subtract these two equations. In this case, what I have to do is to double this equation and subtract this equation from that. What I have to do is to take 2 times 2 minus equation number 1. Now if I do this, I can see we have 2V1 here, and we have this thing times 2, which will be again 2V1. When I subtract them, the 2V1 and 2V1 cancel, but then I have V2, and then that times 2, which means we have 2V2, and then another minus V2 here, which I subtract, is going to be plus V2, leaving us with a total of 3V2. So according to that, on the left hand side, we get 3V2. Now on the other side, we have 4EU times 2, which is 8EU, minus another U, so minus U. So therefore we get V2 equals 1/3, and if I factor out the U, I have 8E minus 1. So according to our situation, it is said that both A and B move in opposite directions. Now that is what we assumed here when we wrote V1 and V2. But in order for this to actually happen, V1 and V2, both of the numbers here, must both be positive. If one of them is negative, it would mean that our particle is actually not moving in the direction indicated by the arrow, but rather in the opposite direction. So according to this, we need both V1 and V2 to be positive in order for our two particles to be moving in opposite directions. So in the first case, for V1 we can see we have 1/3 of 1 plus 4E. Now as we know, E is always a positive number. So therefore 4E is positive, and therefore 1 plus 4E is also positive. So due to this, we can immediately say that this value of V1 is positive. So I'm going to take this up a little bit, and I'm going to say, therefore V1 greater than 0. Now that's guaranteed. However, the second part is not guaranteed. In the second part, we have 8E minus 1. Now in this case, if E is small enough, it is possible that 8t is smaller than 1, and therefore 8t minus 1 is negative, and according to that, we could have our value of V2 being negative, meaning that this particle could move in the leftward direction. So according to that, to rectify the situation, we need to say, since A, B move in opposite directions, we can say V2 must be greater than 0. Now in this case, if I just consider what I have here, I have 1/3 times 8e minus 1 times u. Now in this case, 1/3 and u are both positive. Therefore, I can divide both sides of the equation here by that number, leading us to 8e minus 1 being positive. So therefore we can say 8e minus 1 greater than 0, and if I rearrange some more, I can see, taking this to the other side, we have this value here being 1 and 8e here, leading us finally to the fact that e must be greater than 1 divided by 8. I take this 1 to the other side, I get 8e greater than 1, dividing both sides by 8, I finally get e greater than 1 over 8. And that is the final conclusion of this question. So now considering the marks awarded for this question, for the diagram, we actually don't get any marks. The first place we get marks is when we use the conservation of momentum and apply I equals delta mv and get this equation. You can either get the 5 marks from this equation or simplifying it down to this equation right here. So for that, you get 5 marks. Now similarly, when you correctly interpret the velocities here and write down Newton's law of restitution correctly like this, either as this form or as the equation itself, you get another 5 marks. Now after this, the next marks are allocated for finding the values of v1 and v2. When you substitute and find, or rather add together and find v1 equal 1/3 times 1 plus 4e times u, this gets you 5 marks. Similarly, when you find v2 as 1/3 times 8e minus 1 times u, you get another 5 marks. After that, the final 5 marks are awarded for saying, since a and b move in opposite directions, both v1 and v2 must be positive. We already showed that v1 is positive, and therefore v2 must also be positive, and according to that, if v2 is positive, 8e minus 1 must be positive, and therefore finally we can say e must be greater than 1 over 8. For this, you get a final 5 marks. Now that is all for this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.